Hello and welcome to Level 1 Mechanics, Gravitational Potential Energy. Gravitational potential energy is the energy stored in an object if it's raised to a height. Here I've got this bucket or barrel. I've raised it to a height. I've done some work. Remember, work equals force times distance. So I've applied a force to this and I've lifted it about 1.5 meters off the ground. The work I've done has now been stored as gravitational potential energy. So let's take a look. Let's take a look at this. Okay, gravitational potential energy is the energy stored in an object as it is raised to a height, as I mentioned before. The SI unit for gravitational potential energy is the joule. Okay, the joule is always the unit for energy. It's also the unit for work. Gravitational potential energy has a formula. That formula is delta EP equals mg delta H. Delta EP is the delta of course is the change. EP is gravitational potential energy. So the change in potential energy, and it's measured in joules. Next in the formula we've got M. M of course is mass, measured in kilograms. G is acceleration due to gravity, 10 meters per second squared. And delta H is the change in height. Let's look at an example. A forklift lifts a 500 kilogram crate to a height of 2.5 meters. How much gravitational potential energy does the crate now have? All right. As always, we write down what we know and what we're trying to find out. Okay, we're trying to find out, of course, the potential energy of that crate as it's lifted up. Mass is given to us, 500 kgs. That's how much the crate, or the mass of the crate. Gravitational potential energy, G, is 10 meters per second squared, and the change in height is 2.5 meters. We take our formula. Delta EP equals mg delta H. Plug in our values. EP equals 500 times 10 times 2.5. And we end up with a potential energy of 1250 joules. We could write this as 1.25 kilojoules. All we have to do is divide by 1,000. All right, since we've got this formula, we can use a magic triangle on it. Okay, this is a little different because we have 4 variables, but we can still use that magic triangle. All right, so here's our triangle, and instead of 3 places, we've got 4 places. And we move mg and h to the bottom because mass times gravity, acceleration due to gravity, times height has to go there. And of course, the only space left now is where at the top of the triangle for potential energy. So if we're trying to solve for potential energy, and you can see you cover up the delta EP, and the equation is just the way it is. EP equals mg delta H. If, however, we are trying to find mass, we cover up the M, and now our formula is going to be delta EP divided by G times delta H. And if we wanted to find the height, we cover up delta H, and delta H equals delta EP divided by mass times gravity. Okay, you got to be careful here. You don't want to punch into your calculator EP divided by mass and then times gravity. You have to hit divided by for just before gravity, because you are not multiplying by gravity, you're still dividing by gravity.